Right, hi everyone, Karen here from GeoNadir. Really excited to have you online today for your lunch and learn, dessert and learn, morning tea, breakfast, whatever it is, depending on the time of day. But enjoy, take a seat back. We'd love to get some feedback from you in the chat as we go along. I'll have some questions to ask you, so please feel free to interact and get involved. So today we wanted to look at what's hot in GeoAI. So my first question for all of you is to ask, what is it that comes to mind to you when you think of AI or artificial intelligence? So maybe just one word if you like, or something super quick in the chat there. What is it that you think of when someone says AI? So we've got some automation. Thanks, David. What else have we got? Don't need to think too deeply. Auto classification, automated recognition. No need to draw polygons, definitely if we're thinking in the geospatial sense. Anything else, anything at all. So it doesn't have to have, that doesn't have to be to do with geospatial, anything. But I think probably the forefront of my mind at the moment is definitely in the ChatGPT space. Yeah, making jobs easier, machines doing things faster than we can, programming. Yeah, new security threats. Yeah, definitely. So it's not just all on the positive side of things. Okay, great. So there's some really good options there of what it is that we think and feel about when we think about AI. Now, what if I put a geo in front of that, and geo meaning geospatial? Does that change anything for you? So when you think of GeoAI, any other thoughts on what that means for you when you hear that term? Maybe it's new for you as well. So feel free to just write, I have no clue, that's fine as well. Yeah, so we've gone from automated to automated mapping. That's a great leap there. AI for spatial tasks, drone image analysis. Yeah, definitely on the right track. What I think of as GeoAI as well. So really, if we think about what artificial intelligence is, it's obviously doing those things that's not human. And the geo is bringing the spatial into that as well. So we've got other options there for facilitating geoanalysis and keeping jargon free for potential adopters that are the next users. Yes, I absolutely agree with that one as well. So it's making things accessible to people, because in the world of geospatial and Earth observation, we are incredibly technical and it can be really quite exclusive. So how do we actually break that down and make things easy using things like large language models to perform the analyses that we want? Another one in there for prompt-based object detection. So yeah, again, how do we use natural language to get the geospatial information out? Okay, so in a moment, I'm going to show you a drone orthomosaic, and it's got some trees in it. So what I'd like you to do when you see this is to count the trees and let me know the area of each tree crown as well. So when you think you've got an answer, I'd love you to put it in the chat for you. And I'm going to race you on this one. All right, so ready, set, go. So you're counting trees and thinking about how much area they cover. Alrighty, I've done it. And I've got the area of each tree crown as well. 55, good job, Pat. Michael, 54 trees, 200 meters squared, 40 for Gavin. Yeah, some good estimates there. All right, so what I'd like to just share with you here, hopefully, as you're counting, perhaps you saw some stuff moving on the screen as well. Basically, what I went in and did was to use a text-based prompt. In this case, I used palm trees to find those trees. And so just finding the trees for themselves would be artificial intelligence, but to get the area and the location of those trees is where we add that geospatial layer as well. So you can see over in the left-hand side, we've got a canopy measurement for each individual tree, and then the total canopy measurement for all of those 54 trees altogether. So if I was to do the same sort of thing in ChatGPT as a large language model, I'd screenshot that image and said, hey, how many trees are in there? It guessed, it said there's 70 trees in the image, and you can count, it counted 7 rows and 10 columns of evenly spaced trees arranged in a regular grid. So that is the artificial intelligence side, but then how do we make it geospatial? Well, we want to know the area and where these things are, but that's where ChatGPT struggles a little bit and needs extra geospatial information to answer that. So I said, what's the canopy size? And it said it needs to have the scale reference of the data that it's working with and some real world dimensions. So perhaps the pixel size or ground sampling distance of the drone that was used, or even just a scale bar would help with it as well. So ChatGPT was giving us the AI side of things, but to give that extra layer of the geospatial, we really need location, and that's really all that GeoAI is about. So how does Geo actually fit with artificial intelligence? So if we think of artificial intelligence as being this big bubble, we've got machine learning and deep learning as subsets within that. And then if we think of geospatial analysis, we've got things like vector and raster analytics with 3D analysis, all the types of things that you might normally see done in QGIS, ArcGIS, or Envy, those types of programs. And so then what we're doing when we get to the GeoAI is putting those two together, and it's the intersection of those two things that gives us the GeoAI. And yes, it's jargon terminology. So how do we, what does that actually mean? How does that help us? So if we think about what that can actually do and the types of questions and the value that it can provide us, a lot of time people are trying to identify things in our geospatial data. So that might be drone data, satellite data. And the types of things that you could do is find specific objects or features in your image. So perhaps locations of a particular weed, look for damaged infrastructure, or even bird nesting sites, that kind of thing. So identifying is kind of on the low level of the technical nature of where it gets to. Then the next step up is to be able to count or quantify those things. So how many of those things are there? Like the trees, how big are they? What is the crown? And perhaps even what is the density per unit area? We can then move on, and each step here is just really delving just that much deeper into the analytical side of what we're working with. So classifying these geospatial data. So perhaps grouping similar features together into different categories, like a land cover map or a habitat type, crop types, that kind of thing. And then even predicting, so modeling future likely incomes based on outcomes based on trends. So perhaps, where is erosion going to occur? How much coral bleaching might spread? Where might it be? What is the deforestation risk? So really adding that temporal component into that, which then goes into allowing us to track and monitor these things over time. So looking at shoreline retreat, erosion or deposition, urban growth, vegetation loss. And then another area that is really, I think, probably one of the exciting things that we can do with artificial intelligence is to be able to fuse or combine multiple data sources together. So adding drones and satellites and field data all together to improve accuracy of our models or fill in gaps. And speaking of filling in gaps, artificial intelligence can actually guess things for us. So if we've got missing data, it can fill in those gaps for us as well, create super resolution data sets. So what I'd like to do now is to actually jump in and give you a couple of demonstrations of some different types of artificial intelligence that we can work with. So hopefully get a bit of a feel for how simple and potentially how complicated it is. So there's always caveats on all the things that we do. And it's important to sort of understand where those things sit as well. So what I'm going to do, first of all, is to jump into this particular project that I've set up on GeoNadir and look at how we can use some basic types of classification and feature detection, so forms of artificial intelligence, to give us more information about what we're looking at. So we're going to head to Low Isles, which is on the beautiful Great Barrier Reef and in my backyard in this area here. So let's zoom all the way in. And the first type of artificial intelligence is machine learning that I'd like to share with you. So I've got a drone data set here, satellite image on the background, but I'm just going to clear that for the moment just to avoid any confusion about what we're looking at. And I mean, just looking at this data, you can probably see a number of different features already. We have an island, we have buildings, we have trees, we have some submerged sand, and then we have some reef. There might be coral, algae, etc. So with machine learning, one of the things that we can do is to tell the software where certain features are and then get it to try and guess where other things that are similar might be as well. So in this case, for example, I've found and drawn little polygons for sand, trees, buildings, and I've added in underwater sand and also underwater reef as well. I could get a little bit more picky about where these are placed. This was really sort of rough and ready to do this, so it's absolutely imperfect, and I could play a lot more on developing this, but just for the purposes of this demonstration, I want to show you how simple it is to actually then tell the software to go and find where other things are that I haven't labeled. So for example, where are the rest of the trees? I've given you a couple of samples of trees. Where are the rest of them? So to do that, it's actually really simple. So we grab all of our samples, and then you can actually also decide what layers you want to use for the software to be able to predict what else you might see. So in this case, with a drone orthomosaic, we've got the red, green, blue data, so just what you see. You can add in a greenness index, so how green each pixel is, the digital surface model, digital terrain model, and even height, which can be helpful if we're looking at trees versus grass, for example. So you can choose whatever layers you like. And the first one, I'm going to show you an output just using, say, the straight orthomosaic and the digital terrain model. Now, for us to run this will take about 5 or 6 minutes or so to create this prediction. But of course, here's one I've created earlier, and you'll see what that classification looks like on top of that there. So if we open up in the legend, you'll be able to see that effectively what it's done is it's looked at the samples and said, okay, what does this look like in terms of the red, green, and blue space? And what is the value in the digital terrain model? Okay, now I'm going to think about what those features look like perhaps for sand. So sand typically looks quite bright in red, green, and blue. And in this case, the digital terrain model is quite low. So then, hey, as a piece of software, I'm going to create a bit of a profile of then what sand looks like. And I'll do the same for trees and for buildings, underwater sand and underwater reef. Try to figure out what the similarities are in terms of the training samples that it's received and what are the differences as well. And then for every single pixel in the image, it will look at it and say, oh, so how similar does this pixel look like any of those training examples that I've been given? And then it will put it in the one that it looks most similar to. So that's what we see here. So we can see colored in the same color scheme as what we've got for our samples. We have sand in yellow. It's not too bad. Buildings in pink. So we apparently have quite a lot of buildings right on the edge of the beach. That's going to be trouble if we have some erosion hitting. And you'll see as I toggle between the two, maybe I'll just zoom in a little bit, that we absolutely have some misclassification in this area as well. So there's definitely no buildings along the edge here, but probably what we do have is a little bit of this breaking wave, which is the really bright color, and that's what the model is then thinking is building as well. So then we can play a bit with changing what our input layers are. So for that original one, I said I used the digital terrain model and the red, green, and blue. I could actually change that to using a different combination. So the red, green, and blue, the digital surface model, and the digital terrain model. And this is a lot of trial and error here. You can actually see that this gives me a whole heap more buildings all the way along the sand. So not a great classification there. So this is what brings me to one of the caveats with artificial intelligence is that, first of all, it required a lot of input from me to do this. I need to know where my samples are. And then second, it isn't always right. And for anyone that's played a lot with ChatGPT, you probably know quite well that what it spits out needs to be taken with a grain of sand, a grain of salt. And when you look at this, yes, okay, it's not bad for first cut. I can continue to play and refine, but that's really going to require quite a bit of human input to do that as well. So another thing that we can look at is to consider how does deep learning get involved in this space as well. So I've shown you an example of machine learning here. And what I'd like to do now is give another example of a different way that we can look at things. So if I'm looking, for example, at if I just wanted to see where the boundary of the island is, I would typically go and use our magic wand tool and give it a couple of different samples. My island includes trees, so I'll add that in there as well. When I've done that, I'll hit enter. And this is going to use a form of deep learning to try and figure out where the boundary is of the samples that I've created. So you'll see there's actually a bunch of polygons that will sit on top of each other. So it's created some additional things that we can merge later, but does a pretty good job of outlining the island. This is scale dependent, so I could zoom in and get a different result as well. So this is a form of deep learning, and it's called zero shot. So this means I'm really not telling it what these things are. I'm just giving some samples and it's giving me a result as well. And in this case, it's not a bad result in terms of what the island looks like. And so if I wrap that up, I get 24,000 meters squared. So again, the geo in the AI is giving me that locational information, where it is and how big it is as well. So this is based on what's called a segmentation model. So it's looking for objects in the data and then putting boundaries around them. So that's one way that we can do deep learning in this type of software to be able to get information like that out. Now, another thing that we could do is say, oh, you know what, I want to find some things that are a little bit more specific than just say the boundary of the island. So you can see we've got a range of palm trees in here. So if I'm still out at this same zoom level and I want to say, let's find all the palm trees. And this time I'm going to use a different form of deep learning models here. So this uses two different deep learning models. I'm going to look up my palm trees, which you saw in the video at the beginning as well. So I'm going to try and find palm trees. And this uses two deep learning models I mentioned. One is to segment things first, so to find objects. And part two is to see if the objects that it finds matches what it understands different things look like. Now, what the big issue with this is, at the moment, is we're at the wrong scale for it to find these palm trees. So you can see how zoomed out I am, and actually it's given me quite rubbish. So I'm going to clear that one off, and this time I'm going to zoom into a scale where it's quite easy for our eyes to see these palm trees, so it should be easier for the software to detect them as well. So I'm going to run that model, and again, so it's first of all looking for objects and then trying to figure out if those objects match what it understands in its library of what these objects look like. So you can see it gives us a very different result at a different zoom level. So again, really important to have that, I guess, the intelligence from the user to get some of the good results here. It's given me a bunch of things that are not palm trees. So I do want to play with my confidence and say, are you really sure that those are palm trees? Can you be a bit more confident? And as we do that, then I get my palm trees pop out. So this is a form of deep learning for looking at identifying features, counting them, and assessing their area as well. We could take this a step further to then say, well, what's the density of palm trees on that island? And to give you an idea of that, I'm going to quickly jump over to another project down in Tassie where we've done just that, not for palm trees though. So let's go all the way into Tassie and look at a particular data set here. And this is thanks to Michael Honey, who I think I saw online. So thanks for uploading this data set to GeoNadir as well. So one of the things that we're interested in here is what is the coverage of trees. So we've gone in and used those same tools to identify where trees are in a subset of this image. No need to do it everywhere because that's a bit time consuming, but using that magic wand and the feature finder to be able to figure out where those trees are. But if we think about the scale of Tassie, let's zoom out, let's keep going all the way out here. It's a teeny tiny spot. And if I actually wanted to figure out the density of trees or where all the trees are, either across all of Tassie or even over Australia, that's really not going to cut it. So our next step to get to that point is that we need satellite data. So we're looking at how we get both satellite and drone data working together. The problem is if we look at satellite data, there's satellite data sitting behind this here, you'll see each little black square shows the resolution of that satellite data. So if we come all the way in, you'll see that some of these satellite data pixels will have 100% tree coverage, some will have 0%, and some will have 50, 30, whatever it is. So then we can also use artificial intelligence or GeoAI to be specific to calculate what the percentage is of trees within a pixel and then use that to scale out more broadly. So I'm going to turn off a couple of those layers so you can see what that looks like when we do that there as well. So let's pop this on here. So what you can see here is every pixel has been colored based on the density of trees in those areas. So this area here, we've got grass, so zero density here. But any one of these pixels I can actually click on to determine what the density of trees are. And in that case, it says DSM, don't worry about that. That's our tree percentage, but 100% trees there. And then some of these other ones will have much lower percent tree coverage. So that's another way in which we can use GeoAI. So hopefully that gives you a bit of a feel for a couple of different examples. I wanted to give you a whole range of other really cool organizations that are doing stuff in this space. I can't talk to the ins and outs of all of the things that they're doing, so I really recommend you jump on their website and have a bit of a play around with what they're doing. So Paul will pop the links to these in the chat. This is just a handful, and I do have some LinkedIn information for a number of the organizations as well. So it's really looking, when I pick these ones, for diversity in terms of who runs them, why they tackle the particular problem they're tackling, geographically where they're based as well. So hopefully that gives a bit of a variety of different types of organizations if you're interested in the GeoAI space, which I imagine you are, otherwise you wouldn't be here. So getting started, I do recommend checking out the sites of the ones that Paul just popped in the chat there. There's 3 other ways that you can look at it. If you have access to QGIS, there are some plugins that are doing some really cool work there. So this one on the left here is an organization called, I think it's pronounced Aino, A-I-N-O. This guy here is Guru, so he is amazing. Chusheng Wu, I highly recommend giving him a follow. He has lots of open source stuff that is just incredible. And if you're an Esri user, there's a range of deep learning models that are available to use within ArcGIS Pro as well. So just to end with this, I just want to remind you that AI doesn't actually replace scientists and managers. It just lets us ask better questions and do things faster as well. So hopefully this has provided you with a really quick learning session on what GeoAI is, when it's helpful, what some of the issues are, and who is doing the really cool stuff that you should check out moving forward as well. So with that, I'm happy to take any questions if there's anything in the chat. Thank you.
Karen, so Tristan has asked, this be used for thermal pest animal surveys. So this is when you were doing a little bit of that first one around the classification.
Can this be, oh yeah, I said at the top there. Thank you, Tristan. Can this be used for thermal pest animal surveys? So was that in the random forest classification, Paul, or was that in the magic wand stuff?
Yeah, but well, I suppose a bit of both. Yeah.
Just general. Yeah, absolutely. So I think it's possible to build a deep learning model on anything that you're interested in. The challenging part is all the time that you spend in training that model. So the one thing I guess I'd like to sort of be a little bit cautious on is do you actually need deep learning or even machine learning to answer that question? So sometimes with thermal data and an animal in particular, if there's a really high contrast between that animal and its environment, you'll be able to use a simple thresholding tool, which is easier, faster, and cheaper, and then better for the environment as well if you're not using deep learning models to do this. So the short answer is yes, absolutely. You can use any type of GeoAI for looking at these types of things like thermal pest animal surveys, but also just just with caution, because if there are cheaper and easier ways to do that, take the easy route. Hopefully that helps.
And yeah, so maybe just one extension on there from Gloria. You were looking at the palm trees, and Gloria asked, can other species of trees be identified? So this here was with the text prompts.
Yeah, so a really good question. Okay, so with the palm trees, what's running in the back of that? We have two models. The first one is the segment anything model, which is from Meta, people I guess know as Facebook. So that's the thing that chops things into the different objects. And then the second part of it is another model that's called grounding dino. Now, what that does is the one that's matching what the objects that it finds with its database of what different objects look like, I guess. So can the combination of what we've already got on GeoNadir, can that find other species? Well, that depends on what that species is. Like if it's can you find Caribbean macula? I don't know, just a random species of eucalypt that you want to pull out? No, I would say. But if there's something in particular about that type of tree, you might be able to say, find me large green fairy trees or whatever it is that they look like, and it might be able to find that. So the follow-on part of that is to say, oh, okay, well, the models that we currently deploy don't work for whatever that feature is that you're interested in looking for. Then you have the ability to train your own as well. And that's definitely takes time, but it's absolutely possible to do as well for anything that you're interested in.
Oh, and then with, I think, so is grounding dino already know palm trees, or did we train it?
No, so we have not touched grounding dino or segment anything model at all. We have tweaked some parameters for the best output based on our knowledge of using it. So we've sort of refined a few bits and pieces, but we have not added any additional samples into that at all. So it does a really good job, actually.
Also, is there going to be the possibility to train in the future for new objects within what we're doing? And Simon's sort of asking there, also to detect the position of the bottom of posts in a vineyard. So sort of that positional side.
Yeah, so I know that the detecting the bottom of the post we've spoken about before is a really challenging one. So absolutely, I would say you can, there's software that we can point you to that will allow you to train these things. That's not on platform in GeoNadir at the moment. We are looking at how you can build those in, bring that into your GeoNadir project, but not something that we offer right now. I have Joan online as well. She might actually be able to, Joan, if you could perhaps put a link to your sea cucumber paper, and maybe if you could find Olivier's clam paper to pop that in the chat as well. So I'll get Joan to put two papers in the chat that talk about training your own model for whatever that thing is that you're interested in looking at, and teaching the software to be able to do that. Hopefully that helps.
Well, I'm conscious of time. I think we've got time for one more, Karen, before we finish up. From Lucas, will there be a setup to create training data in GeoNadir and export it as a common AI annotation format, e.g. YOLO, as well as slicing your training data with SAHI? Hopefully that all makes sense.
Yeah, good question. Thank you, Lucas. No, at this stage, we're not in the space to do that sort of within the next 6 months. But I can't really speak to how much further we go down on the line in that space after that. So for those online, if you are interested in using YOLO, which is you only look once, and that's what Joan has also pasted in the chat there in terms of two other studies that have used that. And the second one there, the clan detection one, we also use SAHI for that as well. So if you're interested in that type of object detection, definitely check out those papers. And Joan is the first author on the sea cucumber one, and I can also point you to Olivier, who was the first author in the clam one, and yeah, put you in touch with those people if you're interested in doing that as well. Their models are available on GitHub, so if you're into the tech side of things, you'd be able to implement those as well.
All righty. Thanks so much, Karen. I think we've got some great comments in there about how much people enjoyed this. So we might do a little bit of a follow-up on this in the next few weeks. If anyone has got any further questions, please do feel free to email them back to us. We're also more than happy to help you out discuss what it is that you're doing with drones at the moment, and how GeoAI and GeoNadir can help you out to do things faster, better, and get those insights from your data. So if you have got any questions, please do just reply to any of our emails, and myself, Karen, or Joan can certainly help you out. Karen, any closing remarks from you?
I guess probably just that the other thing is I, by all means, don't know all there is to know about GeoAI, and I don't have all the connections to all the people who do. So definitely, if you've got others to suggest, pop them in the chat or send them to us as well. And we can also pop those in a LinkedIn post or a newsletter in the future as well. So just all about building community in that space. Alrighty, thank you so much, everyone. Have a great rest of your day, and we'll talk to you all soon. Thank you. Thanks,